Hello everyone. Let's start working on 2025 AMC 8 problems from question number 6 to question number 10. Now that you will learn 2025 AMC 8 problems, you will see that the problems will slightly get harder. You can watch our previous video for question number 1 to question number 5 for the same AMC 8 paper. Now we will move on to question number 6 and the problems will slightly become harder, but let's try and do them together. Let's look at question number 6. Question number 6 says, Seiko writes the numbers 15, 16, 17, 18, 19. After he erases one of the numbers, the sum of the remaining numbers is a multiple of 4. Which number did he erase? Let's try and understand what does the question mean and how will we use a strategy to find it out. Now, if somebody was to approach the question, they would just say that we could add all the numbers or remove one of the numbers one by one and then keep looking whether the sum is coming out to be a multiple of 4 or not. For example, I could add 15, 16, 17 and 18, which is I removed 19. So I'm assuming that 19 got erased. For example, I could have done 15, 16, 17, 18 and would have seen whether it is coming out to be a multiple of 4 or not. Then I could have done 16, 17, 18, 19, which means I removed 15 and thought about it. And so on and so forth. I will get 5 possible combinations and I will have to check whether those 5 possible combinations are actually multiples of 4 or not. That is one way to go about it. Now, since we are short on time and we want to think about different strategies involved, we will try and evaluate the sum of 15, 16, 17, 18 and 19. Now, if we take 15, 16, 17, 18 and 19 and we add the numbers, let's see what do we get. So we are adding the total sum first to see which number should be erased such that I get a multiple of 4. Now, 85, if I look at, is the sum of all these 5 numbers. Now, 85, if I remove from the given list, from 85, which number should I be removing such that it becomes a multiple of 5 is the question. A multiple of 4 is the question. Now, 85 is not a multiple of 4, which is for sure, but I have to look at how near is it to a multiple of 4. So I know 84 is the nearest multiple of 4, which means I must be looking at if I can remove one more than a multiple of 4, right? Because if I can either remove 1 from it, right? That will make it a multiple of 4. And so on and so forth if I keep removing other numbers because 1 is not one of my numbers. So the next number that I remove will be 5 because 5 also from 85, not from 84. From 85, if I remove 5, that will also help me make it a multiple of 4. So what am I doing? I keep on repeating to erase numbers or remove numbers from it, which are 1 extra than the multiple of 4, because 85 itself is not a multiple of 4. Because if 1 is working, then add 4 to it, 5 will also work. Add 4 to it, 9 will also work. So I have to look for all such numbers. And if I keep going on the list of 1, 5, and I add a 4 next time, I will get 9. Again, add a 4, you will get 13. Again, add a 4, 17. So 17 is the first number in the list that will tend to work out for me. So my answer is 17. Now, I could have gone by a longer method that would have helped me, but the idea was to look for a strategy. What is the strategy that you used? That you added all the 5 numbers first, looked at its sum. The sum comes out to be 85. 85 is not a multiple of 4. How much less do I need in a multiple of from 85 so that I can get a multiple of 4 is 1 less. What are the other numbers that will help me get a multiple of 4. If 1 is working, then add 4 more to it, 5 will also work. Similarly, add 4 more to it, 9 will also work, and so on. So I need a number which is one more than a multiple of 4. And if I look at a list from the 5 numbers that I have, one more than a multiple of 4 is 16 plus 1, which is 17. So that's a good way to go about the question, is rather not to add the numbers, but look for a easier way to go about it. So that was the answer for sixth. Let's look at question number 7 now. Question number 7 says, on one of the most recent exam in Professor Kochi's class, 5 students earned a score of at least 95. 13 students earned a score of at least 90%. 27 students earned a score of at least 85%, and 50 students earned a score of at least 80%. How many students earned a score of at least 80% and less than 90%? Which means I want more than 80% but lesser than 90%. Now, if I look at the idea or the concept behind this question, it works somewhat like cumulative frequency. If you would have learned somewhere in, other than AMC, cumulative frequency is the concept behind it. But even if you haven't learned cumulative frequency, you will realize that at least 80% would mean 80% or more than those. So students who are scoring 80% or more are 50 in number. Similarly, 20%, 27%, 27 students are scoring at least 85%, which means greater than this. So if this is 80, this is 85. So 27 of the students are scoring. So this much is 27, 85% or more, because at least 85% means 85 or more. Now, if I go on ahead, it says at least 90%, which means more than that. So 13 students are such which are scoring more than 90 or more than 90. And I have last as 5 students scoring at least 95%, which is 95% or more. Now, be careful that in such a case, when they say 95%, at least 95%, 5 students are scoring, that is already a part of the 13 students I have talked about. Similarly, the 13 students I'm talking about are already a part of the 85% because it says 85 of more or more. So 90 and 95% students are already there. That is why it's a concept of cumulative frequency, because it is added up frequency. Now, if my question says that I want to find out 80 or more but less than 90, so these 13 students who are scoring more than 90 are not supposed to be a part of my answer. But what is the total number I'm looking at? I'm looking at 50 total students, out of which the ones that I've got as 13 are not my answer. Why am I not subtracting 5 out of my 50? Is because these 5 students are already amongst the one in the 13, because it says 90% or more is scored by 95% or more is scored by 5 and 90% or more is scored by 13. So in those 13 students, the 5 who are scoring above 95% are already included. So to take it from 50 and I subtract a 13 from it, which gives me an answer is 37. So that is my answer, and I have to read the question carefully when it says at least or less than. To understand the meaning of these type of words is very, very important. Let's move to the next question now, which is the 8th question. The 8th question says, Isai cuts open a cardboard cube along some of its edges to form the flat shape shown on the right. Now, this is a cube, and that's a net of a cube, you must know. The net of the cube has an area of 18 square centimeters. What was the volume of the cube in cubic centimeters? So I don't know the side of the square, which is what I want to find out its volume. I know that these faces, their area adds up to be 18. Now, if I look at the area, it is nothing but the area of 6 squares for which the side will stay the same. Why will the side stay the same? Because a cube is made up of 6 flat squares joined together to form a 3D shape. Now, if I look at the area, it's area of 6 squares, which means 6 times side square is 18, because area of a square formula is side square. Side square is 18 divided by 6, which is 3, which means side square is 3. So value of one of the side is root 3. Now I have got my dimension of the cube as root 3. If I have to find out the volume of the cube in cubic centimeters, volume of a cube formula is side cube. Since side is root 3, I want to find out the cube of root 3. Cube of root 3 is multiplying root 3 thrice, which is root 3 into root 3 into root 3. Now root 3 into root 3 gives me 3, and I get my answer as 3 root 3, which is the A part. So this was a very simple question as compared to the 6th and 7th, and sometimes you must look out for such questions from geometry and mensuration, which are really easy in scoring. You were just given the area of 6 squares and you have to find out the volume of the cube. Now let's look at the next question, which is the 9th question. This is also a good question. It says Ningli looks at the 6 pairs of number directly across from each other on a clock. She takes the average of each pairs of number which are diametrically opposite. We call these numbers diametrically opposite if you look at them. For example, 8 and 12, 2 is one of the examples here. Another example would be 12 and 6, 9 and 3. What is the average of the resulting 6 numbers? Now, when they say resulting 6 numbers, you must ask, why is it 6 numbers? Because they are not taking the average of all these 12 numbers. They are taking the average of the average that you will get of the diametrically opposite numbers, which means that you will find out the average of 8 and 2, 9 and 3, 12 and 6, and all such numbers. And you will get 6 such pairs because 2 numbers club together. In total, there are 12 numbers, 2 numbers clubbed together, which makes 6 groups. So whatever average you get of these 6 groups, you have to take the average of those 6 numbers. Now, how do we solve this question? Very easy way is to add all numbers. I'll find out the average of 8 and 2, 12 and 6. I'll find out the average of 9 and 3. I'll find out the average of 10 and 4. I'll find out the average of 11 and 5. And I'll also have 1 and 7. I'm just writing down the sum yet. The average formula you must know is sum of the numbers divided by the number of terms that you are taking. In this case, because I'm taking the average of 2 numbers, I'll have to take each of the sum divided by 2, get my resulting numbers, and then again add all those 6 numbers that I get, and then divide it by 6. That would be my answer. So obviously it's an easy question. I could just solve it and get all my 6 numbers and then add all of them, divided by 6, and I'll be done. But why would we then say that it is a difficult question, or is it a good question to think about? Because this question can also be done with an interesting strategy that you might use. Now, instead of just going by the definition or going by the suggestions that they have given us, or the instructions that they have given us, I would suggest you to use a shorter method or a shortcut method to do it. Now think about that when you're finding out these 6 numbers, you're ideally adding all the numbers, right? Because let's say, I'm doing 1 plus 7 divided by 2. Then I'm doing 2 plus 8 divided by 2. I'm doing 3 plus 9 divided by 2. 4 plus 10 divided by 2. And then again 5 plus 11 divided by 2. And the last one would be, I can write it in the front, 6 plus 12 divided by 2. Now these are my 6 numbers, right? And again, I have written addition sign between all of them because I have to add all these numbers once over again, and then I have to divide it by 6. Now, one thing I can do as a strategy here is take out half common from all the numbers, because I know half will be divided by to find out the average in each of the case. What I'm left with in my bracket is nothing but the sum of numbers from 1 to 12. And if this is the sum from 1 to 12, I have it's basically half times the sum of numbers till 12 and divided by 6. And if you would have learned sequence and series, you would know the formula for the sum of natural numbers, which is n times n plus 1 divided by 2, which means if I have to find out the sum of numbers till 12, let's say, then I have to do 12 times 13 divided by 2. And where does this 2 go? The 2 will go in multiplication. I will have in multiplication with the denominator because it's being divided. So I'll have 1 plus 2 plus 3 all the way up till 12 divided by 6 times 2, right? And what is the formula that we discussed for the sum of numbers from 1 to 12? Is 12 times 13 divided by 2. Now again, because it's being divided by 2, I'll take again to that denominator. It's 6 times 12. Now look carefully, 6 and 12 6 and 2 just gets cancelled with 12. The answer is nothing but 13 divided by 2, and 13 divided by 2 is 6.5. Now, why would I do all this, or why would I analyze all of this? Is to just make my calculations quicker and faster and not do repetitive calculations, because I would have added and then again found out the sum, again found out the average, and again brought out six numbers and again added them, right? So to analyze it quickly, understand the idea better, I could go by this idea that after all, finding out the average is nothing but finding out the sum of all the numbers, but be careful of taking this extra 2 that you have. You cannot miss this extra 2 out, otherwise it results in a wrong calculation, right? So easy question, but just we have to think more about the strategy we are using behind it. Let's look at the 10th question now. In the given figure below, ABCD is a rectangle with sides of length AB is 5 inches and AD is 3 inches. Rectangles ABCD is rotated 90-degree clockwise around the midpoint of side DC to give a second rectangle. What is the total area in square inches covered by the two overlapping rectangles? Let's understand what has been given to us in the question. The question says that ABCD was a rectangle with dimensions given to me. For the length I've been given 5 and I've been given the width as 3 inches. Then about the midpoint of this length, I rotated my rectangle, and this other rectangle that you see is nothing but the original rectangle itself, but it changed its orientation because it's rotated 90-degree clockwise. Now, which is again easy to see that this part will be 3 and that part will be 5. Now, the question asked is, what is the total area in square inches covered by the two overlapping rectangles? Which means I need the area of the two rectangles, but I have to be careful that they are overlapping. So to find out the total area, I have to do total area will be area of two rectangles minus area which is being overlapped, or the overlapping area, right? Now, if I look at because I have to look at the total area, I look at the area which is overlapped, which means I look at that area which has been covered twice for both the rectangles. And if I look at it, is nothing but this area of the square shape that I can see, because it's being covered by both the rectangles. And if I take the area of both the rectangles, this area will be counted twice. So to find it out, what we do is we take area of two rectangles and subtract this overlapping area because it can't be counted twice. Now, and why do we have to subtract this area? Because it says what is the total area being covered by two overlapping rectangles. So we can't count it twice because we have to actually show the area that's being covered by both of them. Now, two rectangles would mean rectangle area 1 is length time width, which is 5 times 3. And because both of them are the same, we can just double that area. If I look at the overlapping area, the overlapping area looks like a square. And remember that it was rotated about this point, which was the midpoint of CD, which means if AB was 5, this point from C to E, let's say, would be 2.5. And because it looks like a square, it is 2.5 into 2.5. Area of a square formula is side times side. So all I have to do is just remove the overlapping area, which is the square, and add the area of the two rectangles. This is 2 times 5 times 3, which is 30. And I'm subtracting 2.5 times 2.5, which gives me 6.25. 30 minus 6.25 will give you 23.75 as your answer. I hope you have understood what were we talking about in the question and why did we remove the overlapping area. And it's important to see that this part is not your overlapping area, so don't get confused with it because it's not covered by the first rectangle. The only portion which is overlapping is the one being covered by both the rectangles, and we have to remove that. And midpoint is something that you read through the question, so you have to put attention to detail. So I hope you understood your problems from question number 6 to question number 10. They were very easy except for a few where you can use quicker and faster strategies because you also want to attempt the next set of few questions.